Good morning, everyone. My name is Sarah Sheikh, and today we're presenting a full MAC analysis across 12 sustainability initiatives for the industrial and commercial sector in Cairo. Our goal is to identify which interventions deliver the best financial return and the greatest carbon reduction, and to give a clear, prioritized investment roadmap. Let's get into it. Starting with the first six initiatives, and the headline is strong. Every single one delivers a positive NPV and negative MAC, meaning they all save money while cutting carbon. District cooling converts 50 individual chillers into a central plant, abating 2 million tons of CO2 with an NPV of 4.43 billion Egyptian pound. Alternate water use shifts building from 100% potable water to 40% treated sewage effluent, NPV of 11.38 billion Egyptian pound and 3.7 million tons abated. Recycled steel, my initiative, switches 30% of construction steel to EAF recycled. It actually costs less per ton than BAU, giving us an NPV of EGP 26.66 million and a MAC of negative 1195. EV charging rolls out 4,115 level 2 chargers across Cairo, NPV 374.5 million Egyptian pound, IRR of 34%. Green MSW treatment is our highest CO2 impact of 5,000 ton per day waste to energy plant, abating 30.2 million tons of CO2, each 4.2 billion Egyptian pound NPV. And plastic and paper waste diverts 60% of plastic and 50% of paper from landfill, generating revenue and an NPV of 450 million Egyptian pound. Our second group of six shows similar strength with one exception. Micromobility is the outlier. E-scooters and bikes replacing short urban car trips sounds compelling, but the infrastructure cost and low adoption projections result in a negative NPV of 16.58 billion Egyptian pound and a positive MAC. It is not financially viable at this stage. Low flush toilets, also mine, installs 200 dual flush units, saving 71% of water per flush. NPV 2.56 million Egyptian pound and the second lowest MAC in the entire portfolio at negative 9,271. Thermal wall insulation reduces HVAC load across buildings, e.g., NPV of 8.76 million Egyptian pound and the lowest MAC of all 12 initiatives at negative 61,274, making it the most cost effective carbon intervention we assessed. Efficient street lighting upgrades 20,000 highway LEDs to off grid solar with robotic self cleaning, NPV 480 million Egyptian pound, awaiting 59,700 tons of CO2. Recycled concrete replaces virgin aggregate with recycled material, NPV 9.28 million Egyptian pound, MAC 1000 MAC negative 1560. And finally, LED lighting is our largest single initiative by carbon impact. Replacing conventional lighting across facilities abates 3.7 million tons of CO2 with an NPV of 11.38 billion Egyptian pound. 11 of 12 initiatives are financially and environmentally viable. Now I'll hand over to the team for the individual deep dive.
Hi, I'm Kathleen, and my first initiative is district cooling, which centralizes urban climate control by replacing individual building level air conditioners with a highly efficient water cooled central plant. This closed loop utility network reduces cooling electricity consumption by 40%, directly mitigating Cairo's summer grid blackouts in line with Egypt Vision 2030. Under this technical approach, a centralized district cooling plant operating at a high energy efficiency ratio of 4 to 5 will replace 50 individual air-cooled chillers, serving all buildings across the development from one highly efficient decentralized plant. Looking at the business as usual or baseline scenario, the development would require 50 standard air-cooled chillers operating at a low coefficient of performance of 3 to meet the 10,000 tons of refrigeration of cooling capacity. This conventional approach carries an exceptionally high energy and maintenance burden, costing a massive 28.05 million Egyptian pounds in annual operating expenses per unit. By contrast, this proposed pathway installs a central district cooling plant that utilizes a treated sewage effluent recycled water loop to reject heat, completely avoiding the use of precious municipal drinking water. The smart utility integration delivers 15 million Egyptian pounds in annual operating and maintenance savings, while achieving a 40% net energy reduction compared to the baseline. Ultimately, this initiative is high relevant as it reduces total building energy demand by approximately 40%, directly aligning with Egypt's national determined contributions and Vision 2030. Turning to the next slide, we will break down the capital expenditures, operational cost drivers, and carbon profile for the district cooling initiative. The total upfront capital expenditure is estimated at 1.25 billion Egyptian pounds, calculated based on an installation rate of 125,000 Egyptian pounds per ton of refrigeration across the 10,000 ton of refrigeration plant capacity. Sourced from a capex breakdown on the right, 75% of this investment is allocated to central plant infrastructure, 15% to the underground piping distribution network, and 10% to controls and commissioning. Our operating expenses represent our primary ongoing financial benefit. Centralized plant operations and maintenance costs only 15 million Egyptian pounds per year. When compared against the business as usual operating cost of 28.05 million Egyptian pounds per chiller unit annually across 50 units, the centralization yields a massive, highly significant net annual operating saving. Environmentally, the project emits a total of 2,018,569 metric tons of carbon dioxide equivalent over its 26-year operational lifespan. On an annual basis, this replaces 77,637 tons of baseline emissions with 46,582 tons of district cooling emissions, achieving a 40% net carbon reduction. The significant abatement is calculated using a GRED emission factor of 0.45 kilograms of carbon per kilowatt hour and assumes a thermodynamic efficiency increase from a baseline coefficient of performance of 3.2 to a district cooling and energy efficiency ratio of 4 to 5. Let's examine the financial viability of the district cooling initiative. Sourced from the 26-year capital budgeting model, the project delivers a highly robust NPV of 4.43 billion Egyptian pounds, while the corporate IRR stands at a steady 2.92%. The project recovers its initial capital investment exceptionally fast, achieving a simple payback period of only 1.34 years of operations. Most importantly, the project achieves an outstanding standard marginal abatement cost of negative 2,197 Egyptian pounds per ton of carbon abated. Since the MAC is a negative, this represents a no-regret investment that is both cheaper and greener than the baseline. Once we apply our social cost-benefit analysis to calculate the social MAC, the societal savings per ton of carbon abated surges to negative 3,563 Egyptian pounds by incorporating the local value of job creation and freshwater preservation in Cairo. The NPV build-up chart at the bottom illustrates this cumulative cash flow journey. This initial capital outlay of 1.25 billion Egyptian pounds is heavily offset by 26 years of compounding operational savings. Even when factoring in Egyptians' inflation escalation rate of 10.1% and discounting at our 10% WACC, the project's net wealth creation is an undeniable 4.43 billion Egyptian pounds, making it a highly attractive candidate for green bond financing. Now let's examine the methodology and key findings for the district cooling initiative. To ensure absolute analytical rigor, we built a robust 26-year capital budgeting model spanning from 2025 to 2050. In line with Bureau Hapoel's net zero pathways, our model is fully adjusted for Egypt's macroeconomic environment, utilizing an inflation rate of 10.1% in line with the Central Bank of Egypt's January 2026 CPI data. We conduct all of our cash flow modeling in local Egyptian pounds, utilizing an after-tax USD hedge WACC of 10% based on the OECD Green Infrastructure Rate. The net present value is calculated by combining our discounted capex and opex cash flows. And we apply a 5% social cost factor to evaluate our social marginal abatement costs. Sourcing our model through these parameters led to 5 highly compelling key findings. First, the financial analysis confirms a strong economic case with a robust corporate NPV of 4.43 billion Egyptian pounds. Second, the environmental impact is massive, abating a total of 2 million metric tons of carbon dioxide, equivalent over the 26-year life cycle. Third, our standard marginal abatement cost is negative 2,197 Egyptian pounds per ton, confirming high financial and environmental cost effectiveness. Fourth, the project recovers its initial capital investment exceptionally fast, achieving an excellent simple payback period of only 1.34 years of operations. And fifth, the project represents an outstanding strategic alignment, directly supporting Egypt's national determined contributions and urban sustainability goals under Vision 2030.
My initiative is alternative water use. On the business as usual, the development relies on 100% potable water at EGP 12 per cubic meter with zero water recycling. The proposed pathway installs an on-site treated sewage effluent or TSE plant that meets 40% of total water demand with recycled water at just EGP 3 per cubic meter. This is a water security intervention as much as the carbon one, which is critical given Egypt's now water stress and fast-growing urban demand. On the financials, the initiative requires a modest EGP 80 million capital investment in the on-site TEC plant. Annual plant operating cost is EGP 4.5 million, but switching 40% of demand away from EGP 12 potable water to EGP 3 recycled water generates a net saving of roughly EGP 516.7 million per year, growing as demand builds out. On carbon, potable water carries an emission factor of 0.0012 tons of CO2 per cubic meter, while recycled TSE drops that to 0.0003. As the emission chart shows, the gap between the business as usual and TSE pathways widen every year, and over the 26-year model, this adds up to 3,746,368 tons of CO2 abated. The second highest abatement of any initiative is our portfolio. Alternate water use had the strongest financial profile of all the initiatives. The NPV over 2025 to 2050 is EGP 11.38 billion, the highest in the entire portfolio. The internal rate of return is effectively immediate and the simple payback period is just 0.15 years, about 7 weeks, which is almost unheard of for infrastructure. And the cash flow chart showed the project is cash positive from the very first year and will steadily to that EGP 11.38 billion. The MAC is negative 3,037 EGP per ton of CO2, the most cost-effective initiative on a per ton basis. And the social MAC is even stronger as negative 3,084. Sensitivity analysis tested water tariffs between EGP 8 and EGP 15 per cubic meter. Even at the lowest tariff, the NPV stays at EGP 6.85 billion, so the initiative is robustly profitable across every scenario. Consistent with our group framework, the model runs from 2025 to 2050, 26 years, using a WACC of 10% and CPI of 10.1% from the Central Bank of Egypt. NPV discounts both the capital and operating streams at the WACC, and make the negative NPV divided by the total CO2 abated. Key data sources are the NUCA, Egypt Water Tariff Schedule, and the Bureau Apple's MAC briefing pack. To summarize, EGP 11.38 billion NPV, the highest of all initiatives, 3.75 million tons of CO2 abated, a 7-week payback, and a MAC of negative 3,037. This is our top-ranked initiative for immediate development.
Egypt is in the middle of a construction boom, and the vast majority of structural steel used is virgin BF-BOF steel produced by the traditional blast furnace route at 2.18 TCO2e per ton and costing 38,200 Egyptian pound per ton. A proposal pathway switches 30% of total steel procurement, which is 3,000 tons, to EAF recycled steel. Electric arc furnace steel is produced by melting down scrap metal rather than smelting virgin ore. The result, a carbon intensity of just 0.44 TCO2e per ton, an 80% reduction. For premium structural elements, we've specified X-Carb P3 certified steel at an even lower 0.30 TCO2e per ton. Here's the part that makes this initiative stand out from everything else in our portfolio. EAF recycled steel is not just cleaner, it's cheaper at EGP 33,200 per ton versus EGP 38,200 for BAU. That's a saving of EGP 5,000 per ton at the point of procurement. This is why the capex figure on the slide is unusual. It's negative. There is no upfront investment required. Switching to EAF steel actually generates a procurement saving of EGP 15 million, EGP 5,000 per ton across 3,000 ton. No additional OPEX or no infrastructure changes, no operational disruption. On carbon, using World Steel 2024 emission factor, the 26-year model abates 22,319 TCO2e, the largest abatement figure among my two initiatives and a meaningful contribution to the portfolio total. The financials reflect the procurement saving directly. NPV is EGP 26.66 million. Payback is immediate. There is no payback period because you never spend more than BAU in the first place. And the MAC is negative 1195 EGP per TCO2e. Notably, the SMAC matches the MAC exactly because the social cost of carbon only reinforces what the financials already show. This initiative has no financial downside. Same model framework, 26 years, WACC 10%, CPI 10.1%, Egyptian pounds. 5 findings. NPV of EGP 26.66 million with immediate payback, 22,319 TCO2e abated, 80% embodied carbon reduction, MAC of negative 1,195, entirely cost negative, zero delay, zero additional cost, and full alignment with Egypt's Green Building Code 2024. Recycled steel is the simplest decision in this entire study. It saves money from day one and cuts carbon by 80%. There is no reason not to do it.
Hello everyone. My name is Dave Mehbubani and I am a student of University of Wollongong 8248035. Uh, this is my initiative called EV charging and it's a mobility related initiative. I'll be installing 4115 level 2 EV chargers, charging stations, or rather charging points, which will be reducing the inline combustion engines vehicles uh, by a significant amount. So what my initiative is that we'll be installing EV chargers. The first installation will be in the starting year, which is 2025, and we'll be 2026, sorry, and we'll be growing the number of chargers by a 10% annual growth in order to serve the growing EV fleet of the country, Egypt. And it will also replace the fossil fuel journeys because the EV fleet is gradually taking over the ICE vehicle fleet. And the baseline data is that of the business as usual performance is that there is combustion engine dominated fleet and zero or near zero EV charging infrastructure. And there is more than 764,447 tons of carbon dioxide emissions from road transport. And the proposed pathway is that we'll be installing the chargers at the rate of 1067.5 US dollars per charger. And the revenue will be at Egyptian pounds of 3.7 per kilowatt hour. Uh, and this is the maximum we can charge per kilowatt hour or per unit of electricity for our sale because 45% of the Egyptian law says that 45% of the Egyptian grid tariff can be used as a margin. So this 3.7 Egyptian pounds is the maximum revenue obtaining model. Moving on to the next slide, we have the capex, opex, and carbon uh, emission. The capital expenditure is Egyptian pounds of 228.8 million, which is basically for 52.12 Egyptian pound per US dollar rate, and which is basically installation of 4115 chargers. And annual maintenance and network fee is 120 US dollars per charger, and 3.7 Egyptian pound per kilowatt hour into utilization volume is the revenue. And the total carbon abated for the 12-year lifespan of this project is 442,521 tons of carbon dioxide. And the emission factors used are the government data obtained from the IEA website. The grid factor of Egypt is 0.45 kg CO2 per kilowatt hour. And we also take into consideration the official assumptions like 17.5 kilowatt per hour is consumed for running 100 kilometers on an EV. And ICE baseline uh, business as usual consumption is consumption or rather emission is 0.187 uh, kg CO2 per kilometer. And one analysis or takeaway from this is that 0.202 million tons of CO2 emissions will be abated till 2037 year, which is forecasted. And limited carbon abatement, lifetime carbon abatement will be 2.4 billion tons. Now, moving on to the next slide, it's the financial viability of this project. And the net present value is 374.5 Egyptian pounds, internal rate of return being 34.02, much greater than the WACC used, and simple payback period being 6.7, and discounted payback period, which considers time value of money, is around 6.8 or 6.9. And the standard marginal abatement cost of carbon, marginal abatement cost of carbon is minus 846 Egyptian pound per ton of CO2 abated. And MAC interpretation is that strong, is that if the MAC is negative, it confirms that every ton of CO2 avoided also generates a direct financial return to the operator, which is me in this case. And the social marginal abatement cost of capital is 5% times is 5% additional to the MAC, which adds for the social cost of carbon, which is 5%, and it will give us a figure. And the negative magnitude of that figure is the social marginal abatement cost of capital. As you can see in the bottom of this of this sheet, is that I have taken the cash flows. Sorry, the cash flows, net cash flows from the year 2026 to the forecasted year 2037. It's a 12-year business, and uh, the other calculations are in the Excel sheet. Now, if we talk about assumptions, methodology, and key findings, we can see that WACC used is 18% here. It's wrongly stated, and I don't know why I used it. And the CPI, which is the consumer price index for Egypt, taken from the government source, is 10.1%. Egyptian pound is the currency, and here are the formulas which we have taken. The NPV, as I stated earlier, with IRR I have stated earlier, is 34.02, which is much greater than the WACC. That means it's a profitable private sector case. And 442,521 tons will be abated over 26 years. Also, it's a very cost-effective project because the MAC is all negative. Even the marginal abatement cost of carbon is also negative. Simple payback will be 6.7 years, which is acceptable. And the strategy aligns with Vision 2030 of the Egyptian goals, and it also enables Egypt's EV transition from ICE vehicles to electric vehicles. So this is all from my side. Moving on.
Moving on with the Green MSW Treatment Initiative, my name is Ashika and I'll be walking you through this one. So basically, Cairo has a massive waste problem. Up to 20,000 tons of garbage every single day just gets dumped in the desert 50 kilometers away, rotting and releasing methane, which is 28 times worse than CO2. 625 trucks just burn up 368 million Egyptian pounds a year just in diesel to get it there. What we are proposing is a 5,000 ton per day plant at Obor City that turns all the waste into money. Two streams, two revenue lines, and the Zabaleen collectors get formally employed through tipping fees. So, how it actually works? The wet stream goes to the digesters, generating 36.6 megawatts of clean electricity, and the dry stream gets mechanically sorted and shredded into RDF pellets. We sell to the cement factories. That's the two revenue lines. So the capex is 8.89 billion, which is high. It is one of the bigger upfront costs in the portfolio. But here's why that's fine. The plant earns 1,230 million EGP a year, and the OPEX is only 452 million Egyptian pounds. So it has a net positive of 778 million every single year. It pays for itself, and the income's built to be safe. The RDF pellets revenue is completely separate from the electricity revenue. So even if one market drops, the other keeps the business profitable. It all doesn't collapse together. On carbon, the it abates almost all the emissions as the biogas itself counts as zero because it is carbon neutral. That means that the carbon dioxide released was already part of the natural cycle, so we're not going to add anything new. That's 30 million tons abated over 26 years. Next, we have the financial viability. The NPV is 4.2 billion and it is high because the plant runs net positive every year for 26 years, so all that profit stacks up. The IRR is 18.45%, which is well above our 10% WACC, which just means that the returns clear the cost of borrowing comfortably. Payback we can see is by 3 years, which is by 2027. So you will be earning everything that you have put in back by 2027. The main one's the MAC, which is at negative 290. It is negative because the project makes money while cutting carbon. While it is the least negative out of the six, but that is because we abate so much that the 30 million tons gets so that the cost gets thin, spread thin across all of it. So this is the high volume one, which is the most carbon abated, and still it is profitable. And as we can see by the sensitivity analysis, if any of the prices go up or fall down, nothing will crash, and it will still generate a positive NPV. So to sum up everything, we can see that the 26-year-old model has a 10% WAC and a 10.1% CPI, which was used. So, like I said, strong returns, biggest carbon cut in the portfolio. There is real social impact through the Zeppelin, and it also aligns with the Egypt 2030.
Good afternoon, everyone. My name is Malika. Let's talk about plastic and paper waste reduction. Right now, Cairo's commercial and industrial buildings are generating a large amount of plastic and paper waste, which directly goes to the landfills. This initiative establishes an on site segregation material recovery system across the commercial sector, where waste is separated at source into plastic and paper streams, collected separately, and sold to certified recyclers. Because of this, 60% of plastic waste and 50% of paper waste is diverted from landfill entirely. The BAU problem. Under business as usual, 12,000 tons of plastic and 16,000 tons of paper are landfilled every single year. That generates 50,400 tons of CO2 equivalent annually just because of these two waste streamlines. And the sector pays 16.8 million Egyptian pounds per year just for the privilege of disposing materials that have significant resale value. So the proposed pathway would be that the initiative will require only 80 million Egyptian pounds in upfront capex, covering all the segregation infrastructures, baling equipment, and collection logistics. Once this initiative is operational, 7,200 tons of plastic and 8,000 tons of papers are recovered annually and sold to recyclers. The disposal cost of 16.8 million Egyptian pounds per year is not only eliminated, but the operations flip to net revenue positive at 32.32 million Egyptian pounds per year. This is directly aligned with Egypt's national solid waste management strategy and the government's push to formalizing the recycling economy. Now, moving on to the environmental and financial impacts, this initiative requires an initial investment of 80 million Egyptian pounds in order to establish recycling infrastructures and collection system. Right now, waste disposal costs around 16.8 million Egyptian pounds per year, but after the implementation, this project becomes revenue positive through the sale of recovered materials, which will generate an annual savings of approximately 49 million Egyptian pounds. Now, environmentally, emissions decrease from 1.31 million tons of CO2 equivalent under the BAU scenario to around 757,000 tons after implementation. Now, as you can see in the graph, this results in a total carbon reduction of 553,280 tons of CO2 equivalent over the project period. Now, moving on to the financial viability, we can see that this project achieves a net present value of 450 million Egyptian pounds, which means that it generates substantial long-term financial benefits. The payback period is only 1.3 years, which also means that the initial investment can be recovered in less than 2 years. We can also see that the MAC value is negative 813 Egyptian pounds per ton of CO2 avoided, which means that the initiative saves money while also reducing emissions, making it a cost-effective, sustainable investment. In this slide, we can see that the sensitivity analysis demonstrate that even if recycling market prices fluctuate, the project remains financially attractive, highlighting the robustness of the investment. Now, in conclusion, this initiative was assessed over a 26-year period from 2025 to 2050 using the Bureau-Happard MAC framework. The key findings for the initiative plastic and paper waste reduction shows an NPV of 450 million Egyptian pounds, reduces emissions by more than 553,000 tons of CO2 equivalent, and achieves a negative MAC value of 813 Egyptian pounds per ton. In addition to all of this, the project has a short payback period of only 1.63 years, which is less than 2 years, and strongly supports Egypt's nationally determined contributions and Vision 2030 sustainable goals. Overall, plastic and paper waste reduction is a practical, low-cost, and financially attractive initiative that provides both environmental and economic benefits for Egypt.
The Micromobility Initiative is the implementation of a smart network at the Cairo site. This initiative will install a fleet of 300 smart GPS-enabled electric scooters and 30 solar power charging docks across a 500,000 square meter development. By doing so, this completely transforms the last mile transit experience on site. Under the business as usual, commuters must rely entirely on traditional fossil fuel passenger cars for these short trips. This conventional reliance is highly inefficient, costing a massive 1.26 million Egyptian pounds in annual fuel bills and releasing 236 metric tons of carbon dioxide into Cairo's atmosphere every single year. By implementing the proposed low-carbon pathway, the fleet of 3,000 e-scooters and 30 solar charging docks will be deployed, requiring an upfront capital expenditure of 6.2 million Egyptian pounds to achieve 219 tons of annual carbon abatement. This initiative is highly relevant to Egypt's current sustainability landscape as it combats Cairo's severe traffic congestion, improves localized air quality, and serves as an outstanding operational hedge against highly volatile domestic fuel price hikes in direct alignment with Egypt Vision 2030. Our capital expenditure requires a total upfront investment of 7.2 million Egyptian pounds, which we have spread evenly over our 3-year construction phase from 2025 to 2027. This capex directly covers the procurement of our 300 smart e-scooters at 15,000 Egyptian pounds per unit and our 30 solar powered smart docks at 90,000 Egyptian pounds per unit. Our operating expenses represent our primary ongoing financial commitment. Our annual operating costs for the fleet, which include fleet software licenses, GPS tracking, and rebalancing logistics, total 2.42 million Egyptian pounds per year. When compared against our baseline awarded car fuel savings of 1.26 million Egyptian pounds, the project incurs a net annual operation cost of 1.16 million Egyptian pounds. Environmentally, the project abates a total of 5,704 metric tons of carbon dioxide over its 26-year operational lifespan, which is equivalent to 219 tons abated annually. This deep carbon abatement is calculated using highly verified regional emission factors, which compare a conventional passenger car emitting 0.21 kilograms of carbon per kilometer against our electric e-scooters, which emit only 0.015 kilograms of carbon per kilometer over our estimated annual fleet mileage of 1.13 million kilometers. Let's examine financial viability. On a purely commercial basis, our corporate net present value is negative 16.58 million Egyptian pounds, and because capex and opex are both net outflows, our corporate IRR and payback periods are technically undefined. This results in a positive standard marginal abatement cost of 2,906.3 Egyptian pounds per ton of carbon abated. However, as we present this to executive leadership, we must emphasize that traditional corporate finance is not sufficient for public benefit green assets. When we apply our social cost benefit analysis, we add the massive economic value of local job creation generated by our capital spending. Using our 26-year capital expenditure and our economic multiplier of 2.21, our project generates 15.91 million Egyptian pounds in local economic benefits. Adding these social benefits to our model dramatically optimizes our business case. It reduces our net present societal costs to just 698,000 Egyptian pounds and brings our social marginal abatement costs down to an incredibly efficient 122 Egyptian pounds per ton abated. This proves that while micromobility is a cost center on our corporate balance sheet, its massive social and environmental returns make it highly eligible for green bond financing or public-private partnerships under the PIF Green Finance Framework. Moving to our next slide, let us examine our methodology and key findings. To ensure our evaluation meets the highest professional standards, we built a robust 26-year capital budgeting model spanning from 2025 to 2015. Our model is fully adjusted for Egypt's macroeconomic environment, utilizing an inflation rate of 10.1% in line with the Central Bank of Egypt's January 2026 CPI data, and we conduct all of our cash flow modeling in local Egyptian pounds. Since it is a private company, we have sourced our risk comparable peer from Talat Mustafa Group, which is the largest and most robust real estate developer listed on the Egyptian exchange. This comparable peer structure allows us to establish an after-tax USD hedge green WACC of 10%, which we applied as a hurdle discount rate. Our financial calculations have also factored in Egypt's corporate tax rate of 22.5% and a 5% social cost factor for battery and e-waste disposal at the end of the project lifecycle. Sourcing our model through these parameters led to 5 key findings. First, on a purely commercial basis, our corporate net present value is a net financial cost of 16.58 million Egyptian pounds. However, once we apply our social cost benefit analysis, our social returns optimize the project's viability, reducing our net societal costs by over 95% to a negligible 698,000 Egyptian pounds. Second, the environmental impact of the project is massive, abating 5,704 metric tons of carbon dioxide over its 26-year life cycle. Third, our social marginal abatement cost is highly efficient, requiring a societal investment of only 122 Egyptian pounds per ton abated. Fourth, because our net capital and operating savings are achieved from day one of our operational phase, our payback and discounted payback periods are both immediate. And fifth, our project represents an outstanding strategic alignment, directly supporting Egypt's national determined contributions and the urban resilience targets under Vision 2030.
My initiative is LED lighting. On the business as usual, the development buildings are lit at an average lighting power density of 8.5 watt per square meter, drawing power straight from the grid at EGP 2.55 per kilowatt hour, with lighting making up roughly 15% of the site's total electricity. The proposed pathway retrofits all building lighting to high-efficiency LED around 1 million luminaires, cutting the lighting power density to 6.8 watt per square meter, about a 20% reduction supported by smart lighting controls. This is one of the fastest, lowest risk demand-side interventions in our portfolio, and it matters because Egypt's built environment consumes close to 40% of national electricity. On the financials, the initiative requires EGP 200 million in capital. The incremental cost of specifying LED over conventional lighting across roughly 1 million luminaires at about EGP 200 each. Once installed, annual operations and controls cost only EGP 1.5 million, while the 20% cut in lighting energy generates a net saving of approximately EGP 31.2 million in the first year, growing as the development builds out. On carbon, using Egypt's grid emissions factor of 0.45 kilograms of CO2 per kilowatt hour, the initiative abates 359,494 tons of CO2 equivalents over 26 model period, purely from avoided electricity demand. If you look at the chart on the right, the upper line is annual, letting emissions on the business as usual, and the lower line is the same building after the lead retrofit. The shaded area between the two lines is the carbon we avoid every year. And summer across the full model period is given that 359,494 ton total. The financial case is strong. The NPV over 2025 to 2050 is EGP 461 million. The internal rate of return is 37.4%, and the simple payback period is about 6.4 years, solid for a building-wide lighting retrofit. The chart at the bottom of the slide shows how we get to that number. It tracks the cumulative discounted cash flow over the model period, starting near there while the capital cost is absorbed, then climbing steadily as the annual lighting savings outweigh the operating costs, and building all the way up to the final net present value of EGP 461 million by 2050. The MAC is negative 1,281 EGP per ton of CO2 equivalent, meaning LED lighting still generates a financial return for every ton of carbon avoided, a genuine no-regret investment. The social MAC, which adds the social cost of carbon and job creation benefits, is even more favorable at negative 2,508. Sensitivity analysis on electricity tariffs and capital cost keeps the NPV positive throughout, ranging from EGP 228 million in the worst case to EGP 648 million in the best. One important note on the brief is the funds led at a cut from 8.5 to 6.8 watts per square meter, which is a 20% reduction, yet labels it a 40% reduction. We have modeled the literal engineering figures, the 20%. Had we used the labeled 40% target, the NPV would roughly double the around EGP 1.1 billion. Consistent with our group framework, the model runs from 2025 to 2050, 26 years, using a WACC of 10% and CPI of 10.1% from the Central Bank of Egypt. NPV discounts both the capital and operating streams at the WACC, and the MAC is the negative NPV divided by the total CO2 abated. Key data sources are the Bureau Household Initiative brief for the 8.5 to 6.8 watts per square meter LED specification, the Egypt-era commercial electricity tariff, and the IEA's 2025 Egypt grid emissions factor. To summarize, EGP 461 million NPV, 359,494 tons of CO2 abated, a 6.4 years payback, and a MAC of negative 1,281. LED lighting is a low risk, cost-saving efficiency measures that should be embedded in every building across the development.
So, what is this initiative and why does it matter in Egypt specifically? Right now, the business as usual scenario uses standard single flush toilets consuming 13.2 liters per flush across 200 fixtures flushed 50 times a day. That's nearly 1,928 cubic meters of potable water per year consumed by toilets alone. A proposed pathway replaces all 200 with dual flush toilets, 3 liters for liquid waste, 6 liters for solid, averaging just 3.9 liters per flush. No changes to pipework, no impact on the occupation experience. The only input is the unit cost of 4,500 Egyptian pound per fixture, total capex of 900,000 Egyptian pound. Why Egypt? The country has a water stress index of 141%, one of the highest in the world. Per capita, freshwater supply is just 500 cubic meters per year, half the UN scarcity threshold. Toilet flushing accounts for around 30% of commercial building water use. This intervention directly addresses that. The chart on this slide breaks down the financial and carbon profile of the initiative. The capex is 900,000 Egyptian pound, a one-time cost for procurement and installation of 200 units with no structural changes needed. On the operating side, the initiative generates an annual water cost saving of 6,790 Egyptian pound in year 1 based on 1,358 cubic meters saved at the commercial tariff of EGP 5 per cubic meter. Crucially, that saving escalates every year at Egypt's CPI of 10.1%, so the financial benefit compounds significantly over the 26-year model period. For carbon, we used Egypt's grid emission factor of 0.000354 tCO2e per cubic meter of water treated and distributed. This gives us a total abatement of 276 tCO2e over 26 years. I'll acknowledge that the smallest carbon figure in a that's the smallest carbon figure in a portfolio. But as the financial slide will show, this initiative's strength is its financial returns, not its raw emission scale. The four KPI cards at the top tell the story clearly. NPV EGP 2,562,000 over 26 years discounted at our WACC of 10%. This initiative generates over 2.5 million Egyptian pounds in the net present value. IRR 33.6%, that's 23% points above our 10% cost of capital. This investment outperforms the benchmark by a wide margin. Payback 2.36 years. The capex is recovered in just over 2 years, leaving 22 plus more years of pure net savings. MAC negative 9271 EGP per ton of CO2e. A negative MAC means every ton of carbon avoided comes with a financial gain of EGP 9271. No carbon price, no subsidy required. Now look at the waterfall chart. It walks through the NPV build up step by step. We start with the EGP 900,000 capex outflow, then the cumulative OPEX savings flow in as a positive. The CPI escalation at 10.1% compounds those savings upwards over time, and the WACC discount at 10% pulls them back to present value. The net results land at EGP 2.56 million NPV. One additional metric, our SMAC, which adds the social cost of carbon, is negative 9,734, confirming the results hold even when accounting for broader societal impact. Our model runs 2025 to 2050, 26 years using a WACC of 10% aligned with OECD rates for Egyptian grain infrastructure and a CPI of 10.1% from the Central Bank of Egypt as of January 2026. 5 findings to close. 1. NPV of EGP 2.56 million, IRR of 33.6%, well above our 10% benchmark. 2. 71% water reduction per flush, 276 tCO2e abated. 3. MAC of negative 9271 saves money and carbon with no carbon price needed. 4. Payback in 2.36 years with net savings continuing for over 2 decades after. 5. Directly supports Egypt's Vision 2030, the national NDC target, and SDG 6 on clean water efficiency. To summarize, low flush toilets are low cost, low risk, and high return. We recommend immediate implementation.
Hello, everyone. My name is Dave Mahbubani, and my student ID is 848035. I'll be talking about my initiative called Thermal Wall Insulation, and it's an energy and passive design initiative. Mainly, it's a passive design initiative which saves energy. So, I'll be explaining you about how it works and about the various data that I have taken into consideration and calculations. So, basically, we'll be filling uh, loose fill fiberglass into the walls of rebuilt existing homes by drilling cavities into the walls, and we'll be using spun glass fibers, which are often made with 50% of the recycled glass. And this way, we'll be thermally insulating the wall, and we'll be uh, the cutting down the space cooling uh, energy required by 90%. And this way, with the carbon abated, will also be 90%. And if we talk about the BAU, business as usual baseline data, without the initiative, we can definitely say that 13% of the 7.3 ton carbon dioxide emission per house yearly is used just for space cooling. And this is because of the inefficiency in thermal insulation by concrete and other building materials. So that's why this initiative is very important, especially in countries like Egypt, where there is heavy sunlight. Moving on to the next slide, I'll be talking about the capex, opex, and carbon of this initiative. The capital expenditure is 1065,000 times 3, which is 3195 thousand Egyptian pounds. And it is done in the very first year of the operations. And this is because we'll be purchasing 3 trucks for transportation of labor, equipment, and the fiberglass, of course, to the site where we get the project. And the operating cost driver is fuel cost, labor cost, equipment cost, procurement of fiberglass, and of course the diesel, which is 400,000 CO2.6 Egyptian pound per year. And no, not for a year per yearly, but it is for the first year because the number of projects that we'll get is also increasing. The total carbon abated is 1624.82 tons for the 12-year period, and the emission factor used for the grid is 0.45 Egyptian pounds. Sorry, 0.45 kg CO2 per kilowatt hour or per unit, and this is as per the IEA data in 2025 for Egypt. Now, if we talk about the financial viability of this project, the net present value NPV is for the 12 years is 8.76 million, 57.1% IRR, and 3.59 years of simple payback period. If we talk about the MAC, a marginal abatement cost of capital, it's 61,273 Egyptian pounds negative per ton of CO2 emission saved. And basically, this means that for every ton of CO2 avoided or abated, returns, there is a financial return to our company. And the social marginal abatement cost of capital is 64,337 Egyptian pounds negative per ton of CO2 emitted, which is saved. And the difference between social MAC and MAC is that the social MAC is the MAC, but with consideration of the social cost. In our case, it is 5%. So 5% extra of the MAC is SMAC. And at the very bottom, you can see the cash flows, the net cash flows for 2025 year to the 2037 year, which is our years of operation. And just be mindful about the fact that the first cash flow is negative because the capex purchase of 3 trucks. Now, I'll be talking about the methodology and key findings and assumptions. The model period is 12 years, WACC is 10% because the OECD Egypt green infra rate is 10%, so we have taken that. And the CPI is 10.1%. Egyptian pound is the currency. NPV plus NPV of capex plus NPV of operating expenditure, which is discounted at WACC, is the net present value of the organization or the initiative. And the key findings have spoken for themselves because the millions of Egyptian pounds NPV and the 57% IRR is a strong private sector case, and it indicates that it is a strong financial project. And if we talk about environment, we'll be abating over 1624.81 tons of CO2 over the 12 years of our project, and the it is cost effective also because the MAC and SMAC both are negative. Simple payback period, like I've told earlier, is 3.59 years, and the discounted payback will be slightly higher than this because the time value of money is considered, discounting is considered. And by strategy, it aligns with the Vision 2030, which has been taken into consideration by Egypt, the Vision 2030 goals. So that is all from my side. Thank you so much.
Moving on to efficient street lighting. So, as part of the Green Egypt 2030 push, Cairo has already started with switching its street lights over to LED. So that moves is basically done in a lot of parts of the city. The problem is that they are still all grid tied, so they're drawing 7 million kilowatt hours a year, and they cost the state 17.2 million Egyptian pounds. And right now there is a power crisis because of which they have put 50% of dimming as a mandate in the place, and the lights run at half brightness, which is for a highway is a real safety concern. What we are doing is we're taking it to the next step. We are deploying 15,000 solar poles with 20,000 self-cleaning LED solar lights across 200 kilometers of Cairo's main highways, which is the Ring Road, the 26th of July corridor, and the Cairo Alexandria Desert Road. Each one runs off its own solar panel and battery with a robotic wiper for the desert dust. So they are fully off grid, full brightness, zero draw on the state. So breaking down the numbers, capex is 561 million and total. That covers the 20,000 solar LED lights, the 50,000 steel poles, and the civil works to install them. And like you can see in the phasing start, we split that into three equal chunks, 187 million a year across 2025, 26, and 27, so that the government isn't hit with the full amount upfront and it spreads across the build. Once it's up and running, from year 4 onwards, OPEX is 13.7 million a year. And the thing to notice is that that's lower than the 17.2 million grid bill it replaces. So even before revenue, we are already saving the state money. Then on top of that, the maintenance contract brings in 52.5 million a year, which is at 3,500 per pole. On carbon, the BAU grid network emits 2,800 tons a year, and our solar setup, as we can see, brings that down to just 504. We are abating 2,296 tons annually, which is about 82% cut. And over the 26 years, that is around 60,000 tons. And the 504 we do emit is honestly by the life cycle stuff, which is the solar panel manufacturing and the diesel cleaning fleet. We are using uh, real emissions to the factors through 140 kg per bulb for the grid baseline, and the manufacturing premium for solar, and the IPCC diesel factor for our trucks. Onto the financials now. The NPV is at 480 million EGP, and it is positive because of the maintenance contract, which brings in a steady income for years while running costs stay low. The IRR is 18.72%, which is comfortably above our 10% WACC. Payback is 3 years. By 2027, the money will be back and you will be earning profit. And the max is negative at 8,043. The MAC is negative, which is the key takeaway, and it sits at that magnitude because this is a low abatement project and a high return project. The street lights, they don't have much of an emission. They are a small emission source. So we are working with modest tonnage, but the returns on it are strong. So it reads at very cheap carbon, a low volume, high value level rather than a heavy abatement play. And the sensitive analysis shows how robust it is. At the worst case, where the fee can go down to 2,500 with the maintenance, and the WACC can go up to 12%. The NPV still holds 380 million, and the payback with beyond will not go beyond 2028. Best case, it's at 580 million NPV, and it's profitable across the board. The flow at the bottom shows that the build up and how we land at 480 million. The methodology now stays the same as what we have used across the portfolio. We have the 26-year model, 10% WACC and Egyptian pound as the money. The takeaway on this one is just that it ticks every box. It is financially strong, it pays back fast, and environmentally it eliminates the grid on load on the lighting entirely. But more than the standalone numbers, where it really fits as easy, low risk first move, it slots straight into the Green Egypt 2030 plan as the next step after LED, and it builds momentum for the heavy projects in the portfolio. Thank you.
Good morning, everybody. My name is Malika, and I'll be talking about my initiative, which is Recycle Concrete. The idea is very simple. Instead of using only cement, we will replace the part of the cement with recycled materials. Now, since cement is the biggest source of carbon emissions in concrete production, using less cement helps reduce both the emissions and the construction costs. So in the model, we will increase the recycled material content from 10% to 30% across 100,000 cubic meters of concrete. In the BAU baseline, without the initiative, we can see that the concrete is produced with only 10% recycled material, which means there's higher cement use, higher material costs, and greater carbon emissions. But the proposed pathway that we have with this initiative, the recycled content will be increased to 30%. This will reduce the cement demand while maintaining the same performance that is intended with the use of concrete. Now we'll move on to the financial and environmental impacts of this initiative. One interesting findings that I did while doing this research is that this initiative does not require any kind of additional capital investment. Now, the cost of producing conventional concrete is approximately 180 million Egyptian pounds, while the recycled concrete option is around 168.8 million Egyptian pounds. So this results in a procurement saving of 11.2 million Egyptian pounds. Another advantage is that, again, there is no additional operating or maintenance cost because the only change is the concrete mix. Now, from an environmental perspective, this initiative avoids approximately 5,950 tons of carbon emissions over the project period. Now, the charts on the right will show why that happens. The recycled material content increases from 10% to 30%, reducing cement use. Since cement has a much higher carbon footprint than recycled materials, total emissions fall from about 28,500 tons to 22,600 tons, which is a reduction of roughly 21%. Moving on to the financial viability, the project generates a positive NPV of 9.28 million Egyptian pounds, meaning that it creates a value over its lifetime after accounting for the future cash flows. The payback period is immediate because recycled concrete is already less expensive than conventional concrete, and also there is no additional investments. The initiative also has a MAC of negative 1,560 Egyptian pounds per ton of CO2. The negative MAC is important because it means that the project saves money while also reducing the carbon emissions. So in other words, every ton of carbon that's avoided, it generates a financial saving. Now at the bottom of the slide, we can see the sensitivity analysis, which is from the Excel. Even under the worst case scenario, the project still achieves a positive NPV of approximately 4.97 million Egyptian pounds. The base case is 9.28 million Egyptian pounds, while the best case reaches approximately 14.09 million Egyptian pounds. This shows that the initiative remains financially attractive even if the assumptions change. Now moving on to the methodology and assumptions throughout this analysis, we are using the evaluation period from 2025 to 2050. The financial model applies a 10% weighted average cost of capital and 10.1% inflation rate. Overall, the results are very positive. Now, the key findings for my initiative specifically is that financially the initiative delivers a NPV of 9.28 million Egyptian pounds, with savings beginning immediately because the recycled concrete is cheaper to purchase. Environmentally, it reduces emissions by approximately 5,950 tons of CO2 by lowering the cement consumption. It is also highly cost effective with a negative MAC, which means that it benefits both the environment and the project's finances. Finally, the initiative supports Egypt Vision 2030 by promoting low carbon construction materials and encouraging more sustainable building practices. Thank you.
Now, for the recommendations, we can see that this table compares all the 12 initiatives using the key financial and environmental indicators. Overall, alternate water use ranks first because it delivers the highest financial value together with significant carbon savings. We can also see that most of the initiatives have a negative MAC, meaning that they reduce emissions while also generating financial savings, making them attractive investments. Now, moving on to the MAC chart. This first chart compares all the original initiatives based on their MAC values. A more negative MAC means greater financial savings for every ton of CO2 reduced. We can see that alternate water use, district cooling, and recycled steel stand out as the strongest performers. Now moving on to the second MAC chart, this shows all the new initiatives that were introduced. Thermal wall insulation has the strongest MAC, followed by low flush toilets and efficient street lighting. Recycled concrete also performs well with a negative MAC, while micromobility is the only initiative with a positive MAC. Based on all these results, we have developed a phased implementation roadmap. The short term focuses on initiatives with quick payback and immediate financial returns, such as alternate water use and recycled steel. Medium term projects require greater investment but also deliver significant long term value, while long term initiatives focus on expanding and optimizing larger infrastructure projects. This phased approach helps maximize both financial returns and the carbon reduction over time. Now, as for the final recommendations, looking at the portfolio as a whole, the initiatives generate approximately 32.7 billion Egyptian pounds in total NPV, while reducing around 40.2 million tons of CO2 over the analysis period. This demonstrates that sustainability initiatives can create substantial environmental benefits while also delivering strong financial value. Finally, the initiatives are grouped into three investment tiers based on their financial performance and carbon reduction potential. Tier 1 contains the highest priority projects, followed by Tier 2 and Tier 3. This provides a clear roadmap for decision makers to prioritize investments and maximize long-term impact. Thank you.